let's check this one. So the divergence test would suggest that we check to see if this sequence, if this limit right here goes to 0 or not. If it does not go to 0, forget about it, we can stop and there's no hope. So we take the limit, let's use this one, as n goes towards infinity, n times ln of 1 minus 2 over n. First, I usually like to try the plug-in method, see if it's a continuous function. That would be infinity times ln of 1. That would be equal to infinity times 0. Oh, that's a famous indeterminate form. And so we can do a little rewrite to use L'Hopital. How about ln of 1 minus 2 over n? All over 1 over n. Then we apply, then we try the plug-in method. And that gives you ln of 1 all over 1 over infinity, which is equal to 0, 0. Perfect. Then I can use L'Hopital. So L'Hopital would be 1 over 1 minus 2 over n times 1 minus 2 over n prime all over negative 1 over there, 1 over n square. And let's clean it up a little bit. 1 over 1 minus 2 over n. Some teachers would rather you write excess here because you're taking derivatives, so you're using the continuous function version of the sequence. It might look funny to some people. But that's what I'm all about, making it funny. N squared, so this would be negative, so this would be positive 2 over n squared. And the n squares would cancel here, so I'm looking at this whole thing becomes negative 2. So I'm looking at negative 2 times 1 over 1 minus 2 over n. And this is going towards infinity. I use the plug-in method again. This goes to 0, so I'm looking at negative 2 times 1 over 1 minus 0, which I reckon is negative 2. Alright, after all that, we get that this limit is going towards negative 2. What does that mean? It's not 0. It's not 0. Therefore, you're done. Therefore, diverges by the divergence test. And that's it. End of story. This is a lot like adding negative 2 times negative 2 times. No, sorry. This is a lot like adding negative to infinite many times. Alright, that was fun. We'll see you guys here next time. Maybe another example.